Lesson 113, incorporating rotations. Okay, so looking at rotations, right? The semaphore alphabet is a way to use flags to signal messages. This came about way before there were cell phones, and it was a way for people who were really far away from each other that couldn't shout to signal each other to have a conversation. It was essentially like texting, but like one letter at a time. All right. So let me show you what that looks like over here. All right.
Attention.
All right. So hey, yo, I'm over here.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z.
All right, there you go. So they showed you what it looks like from the front, right? If you were watching somebody, and also how you would do it so that you wouldn't have to like think about, oh wait, my left hand, right hand, whatever, right? You could just put yourself in this person's position. Anyway, where were we? 113, I think, is right here. Yes, okay. So here's how to signal the letters Z and J. So here is the position for Z, right? Your left arm out this way and right arm down this way. Okay, for each one, precisely describe a rotation that would take the left-hand flag to the right-hand flag. So the left-hand flag down to the right-hand flag. So if you were looking at this, right, where would be the pivot point? Well, where would be the hinge or the center of rotation? The pivot point would be the shoulders, right? And this arm would rotate down this way. And if we're looking at it, that is the same direction that the clock goes, right? The clock travels around this direction. The second hand on the clock on the wall goes this direction. So this would be a rotation using this as our pivot point, and it would rotate clockwise. And it looks like it's not 90 degrees. It's going to be less. It's going to be like 45 degrees, right? So here's the J, right? And it says, how would you get the left-hand flag to go to the right-hand flag? Well, here the left-hand flag would have to move from here up to here. And notice that this is the opposite direction, right? This one spun around this way, clockwise. This is called counterclockwise because it goes counter to the normal way that the clock turns. And here you can see also that the shoulder would be the pivot point or the center of rotation, and the left hand would move up here at a rotation of 90 degrees because that looks like a 90-degree angle. All right? Okay, next. Here this says rotate ABCD. This is a parallelogram, ABCD, 90 degrees clockwise around Q. All right, well, all of our rotation tools are here. Here's our rotation tool, right? This is all of our transformation tools, and this is the rotation tool. It says to rotate ABCD 90 degrees clockwise around Q. So I'm going to select this object by clicking right in the middle there. Then it says around Q, I'm going to select Q, and it says 90 degrees clockwise. So I'm changing that. Don't get rid of this little degree sign because I don't know how to put it back on there. Okay, so just change the number part to 90, and it says clockwise, so we're selecting clockwise, and we hit OK. And we can see that this rotates down, right? From A to A prime, if you use Q as the vertex, that angle is 90 degrees, right? Okay, cool. Then it says rotate A, B, C, D. That's the original again. 180 degrees around R. Okay, so again, we're going back to our rotate around point tool. We select the object. It says around R, so we select R as our center. And we need to change this 45 to 180. Okay, now it didn't tell us clockwise or counterclockwise. Why is that? Well, if you think about it, a whole circle is 360 degrees. A half a circle is 180. So to get from here around half a circle to the other side, that's 180. But you could also go, instead of going up this way around, you could also go down this way around 180 degrees, and you would get to the same place. Now, obviously, that makes a difference if you're like swinging an object around through space. But here, we're just doing it on the on this flat screen, so it doesn't issue. There's no issue, right? So anyway, there's our 180 degree rotation. You can see that from A to A prime sub 1, that would be half a circle. So like if I use this as my radius right here, and I put R at the center because that's my rotation, you can see that this would be 180 degrees, whether I went this way around or whether I went this way around. And we can look back and we can look at the other one the same way, right? Here's my radius from A, and Q would be my center, and notice that there, that is 90 degrees out of a circle, a quarter of the way around a circle. All right, cool. Next, rotate this shape, HJKLMN, 120 degrees clockwise around O. All right, so there's O. I'm going to go 120 degrees clockwise. So again, this is not the tool I'm using. This is a measuring tool, okay? This is the transformation menu. Here is the tool. Okay. Select the object. Be careful not to click on the edge or a corner or anything like that. You got to select the middle, and you'll notice that the whole edge lights up a little bit. All right, so I'm going clockwise around O. So we got 120 degrees, it says, and it says clockwise, so I got to select clockwise. Boom. Okay, put it over there. Let me zoom out just a little bit, and let me move the screen a little so that we can get things in the middle and see where we're at. Okay, cool. So now if I look at point K, for instance, and I want to make a line segment that goes from K down to O, and then from O up to K prime, we have this angle, right? This is how much it rotated. It rotated around this way. You can see that M goes over to there, to M prime, right? K goes over to K prime. And so this angle is 120 degrees. Now, why? I don't know if you noticed or not, but this has like a square grid and this one has like a triangular grid. Why is that? Well, if we look at this, we can measure out things a little bit easier. So this is a 120 degree angle, right? And I can measure that using this measuring thing here, right? If I go like this from K to O and then over to K, it'll tell me, well, you can't see it because the O is in the way, but you'll see that that is 120 degrees. So that is a 120 degree angle. Now, when I look at this, right, I could actually look and I can go, oh, wow, let's do, let me make an extra point here somewhere. Try right there, okay? So if I make a circle and I use this as my radius, okay, you can see that there's a bunch of times that our circle intersects with the circle. The grid intersects with the circle, right? There's one here, right? There's one there. There's also a bunch of other ones, like right here, and right here, and right here. And this should look familiar because this is a hexagon, right? And we know how many triangles is it? How many triangles does it take to get us all the way around there? Well, let's look at this. We've got a triangle here, got a triangle there, a triangle here, and a triangle here, right? So 1, 2, 3, 4, 5, 6 triangles, and that will take me all the way around the circle. Well, if you divide that 360-degree circle by 6, you get 60 degrees. So if I measure out this angle from here to here to there, I get 60 degrees. Maybe I should do another one so it's a little clearer. From there to there to there. 60 degrees, right? So each one of these is a 60-degree angle. And the cool thing about this grid is that it's easy for us to figure out different amounts, right? We can say that 2 times 60, because we have 2 triangles here, that would be 120, right? So we can easily look at things and figure it out. All right. Go back, clear all this stuff out of here so that it's not as confusing for you guys looking at it. There we go. All right, cool. All right, now it says rotate H, J, K, L, M, N 60 degrees counterclockwise around P. All right, so this same thing, but 60 degrees counterclockwise. All right, so I'm going to be careful with this. I've got to switch over here, select my rotate around a point tool. I select that object. I pick P as my center, and this time it says 60 degrees counterclockwise. So I already got that set, and hit OK. All right, great. So it's rotated there. Now let's look at ML, right? That side. Okay, ML. Right, that goes right through P, and then M prime, L prime, right? Excuse me, with the hiccups. All right, you'll see that this angle here is also right? This is one of those little triangles, right? If I go like this, measure it here and here, that is a 60-degree angle, so that we can easily see that. Like if we look at an object on the grid, we can go, oh, if it's one triangle, then if it's one of these little triangles, then it's 60 degrees. If it's 2, then it's 123 would be 180, right? That would be a straight line. 60 plus 60 is 120, plus another 60 is 180. That would get us a straight line. And then you keep going all the way around until you get 360. All right, cool. Awesome. All right. So Mai suspects that triangle ABC is congruent to triangle DEF. All right, so she's looking at these two, okay? She thinks these steps will work to show there is a rigid transformation from ABC to DEF. Okay, so she thinks that if she follows these steps right here, that this will land perfectly and cover that exactly. So we're going to try and walk through those steps and see if that works. Here we go. Translate by directed line segment V. Okay, so I'm going to go up to this menu because this is where all my transformation tools live, and this is my translate by vector. I'm going to select this object, and I'm going to use vector V. Boom. Okay, so that went up there. Now let's see. Rotate the image, and then she left it blank. She didn't tell us how many degrees. Counterclockwise around point D. Now, this is point D right here. This is point D. We just covered it up with, right there's point D. We covered it up. I'm going to create this line because it says later I'm going to have to reflect over line DE. I'm going to put that line in right now so that we don't forget where line DE is. All right, so there's line DE. Okay, So now she says we have to rotate a certain number of degrees counterclockwise around point D. Okay, so there's point D. Well, if we're going to rotate, if we're going to reflect across this line, right, and make it land on here, we're going to want this triangle to be sticking up this way, right? Okay, so how far are we going to rotate it? And it says a certain number of degrees counterclockwise. So counterclockwise is going around this way, right? Because the clock goes this way. So we're rotating counterclockwise. So where should point B end up? Well, point B should end up where E is, right? That's where we want it to end up. So how long would it take to get all the way around here counterclockwise? Well, let's see. How many triangles would that be? Well, that would be, there's one triangle, then two triangles, then three triangles, then four triangles. So four triangles, right, to get this around. 1, 2, 3, 4 triangles around in order to get B prime to land on E. So if each triangle is 60 degrees, and we have 4 triangles to do, then that would be 4 times 60. Well, what's 4 times 6? 4 times 6 is, let's see, 6, 12, 18, 24. So 24, not 24, but 240. So let's try it. Okay, so we're going to rotate this counterclockwise, this object counterclockwise around this point, and we're going to do 240 degrees counterclockwise. Boom. All right. And then we're going to flip, and then it says reflect that image over line DE. All right. So we're going to go back here, choose our reflection tool, select this object, and then click on this line to use this as our line of reflection. Bam! Landed it perfectly. It covers it perfectly. All right. Great. Awesome. Okay. So that's how many degrees it was going to be, right? Okay, find the center. Okay, my first 2 steps could be combined into a single rotation. Okay, so in other words, whoops, didn't want to zoom that. In order to get, oops. In order to get the first 2 steps, meaning translate and then rotate, we could have done that in 1 step. Right? 1 step could have done that. Not just sliding, but also rotating. And we could have done it using 1 rotation. Because if you think about it, a rotation doesn't always involve just spinning in one place, right? If you look back here, we moved an object way over here by choosing a point that was not on the corner, right? Here, we just chose one of the corner points and rotated it around. Well, I mean, actually, we could have rotated it. Let me go back one more spot here. We could have rotated either 240 degrees this way or how many degrees this way? Well, how many triangles is this? 1, 2 triangles, right? So that would be 1, 2 triangles. 2 times 60 is 120. So I could have rotated this. Let's try it. This one around this point, 120 degrees, and gone clockwise. Boom, still could have landed perfectly there, right? And then flipped it across. So the question is, how do I get this to land up here by rotating it? But again, I'm not going to pick this point or any of these points, right? Because I want it to rotate and end up exactly there in the first place without having to do multiple steps. Right? So we did that here, right? As long as our pivot point is not touching the object, we can rotate things and cause them to move across the plane, right? Move across this surface. If we have our pivot point or our center of rotation not touching the object. All right, same thing happened here, right? Our pivot points were not touching the object, so the object moved. It moved to a different location. There's a gap between them. All right, so how do we figure out where that is? Well, I'm going to give you a hint. Yes, I'm in the school building. All right. I'm going to give you a hint here. And it has to do with that lesson that we did with the pizza shops. If you think about it, we want this point to end up right there. We also want this point to end up right there. And of course, this point to end up right there. So if we're doing this, remember that as something rotates, it has to have a center of rotation. And if it has a center of rotation, that center of rotation has to be part of a circle. It has to be the center of the circle. So the center of all three of these circles, right? There's a circle that hits B and B double prime. It hits A and A double prime. And it hits C and C double prime. There's a point that allows all that to happen, right? When you think about it, with the pizza shops, we used the perpendicular bisectors to find the center point for the shop, or if somebody was going to order, they would be the same distance from all three shops, right? Remember that? We're going to do that right here. So let's check it out. Our perpendicular bisector tool right there, right? Let's go from A to A double prime. Okay, so that's halfway between there. All right, let's go from B to B double prime. And we'll go from, and notice, look at that. They're already meeting here, right? So watch what happens when we do C and C double prime, right? Remember, this is halfway between whatever and whatever, right? Right, we're not going here, we're going out to here because this is where we, hey, look at that. All three land in that location. So let's get our intersection point labeled. Bam. So this is our magic point X. Now let's see what happens if I put in a few circles. Okay, here we go. We'll go with B to our point X. And look at that. Doesn't it hit B double prime? Let's go A and our point X. It hits A double prime. Let's go C and point X. Boom. Doesn't it hit C double prime? So that means that this point, this magic point right here, should allow us to rotate this up to there in one step. The question is, how much rotation is that? Well, we can kind of think about it. How much did we rotate it before? Well, we rotated it either 240 degrees around that way or 120 degrees this way. So let's try it. Here we go. We're going to rotate this object around this point, and we're going to do it 120 degrees clockwise. And watch what happens. Boom. Hey, it landed perfectly. Notice that this triangle is darker. Ta-da! And then we would do our last step, which is just to reflect it across that line, and we would get exactly where we needed to be. All right? Cool. So, how did we find the center of rotation? We used the perpendicular bisector tool, for corresponding points, right? We use B and B prime, A and A prime, or double prime, right? Our goal, right? Our original versus our target, our original versus our target, our original versus our target. And we found the perpendicular bisector for those, and they all ended up in the same point, right? The perpendicular bisectors are all those line segments between our original position and our target position, ended up giving us a common point that we could use as our center of rotation. And with that bell, I send you on to do the practice.